There you go, that's next. Our next speaker is Shikha from Chapman BDSP.
Good morning, everyone. My name is Shikha, and I'm here to present Shenzhen World Exhibition and Conference Center on behalf of Chapman BDSP team. As the name suggests, the project is located in Shenzhen, that is geographically right above Hong Kong. Now, this project is designed by French architect VNP and local consultants Aube. This convention center is going to be the biggest convention center in the world, with the 1.8 kilometer long central corridor roof that's going to be naturally ventilated. It also had fully air-conditioned 19 halls that are attached to the central corridor. The project that opens next year in 2019, and apart from the complexity of the project and the scale of it, for us the biggest challenge was our involvement. We got involved only for 4 months when the tender drawings were actually being finalized. Moving on to the climate, Shenzhen has a warm and humid climate, and with the highest probability of typhoons during the summer period. Now, because the project has a combination of both open and closed spaces, both conditioned and unconditioned, so we had to make sure that the occupant does not suffer through a visual and thermal discomfort. And obviously with the open roof, the rain protection was one of the biggest challenges that we had to face. These are the two walkways which lie beneath the central corridor. And primarily the scope of our involvement was to find one of the best solutions for the roof that caters to both the thermal, visual and rain protection. The tools that we used were actually a combination of X-flow, parametric modeling, for example, grasshopper, task modeling. But what's important to know is that within the period of 4 months, when we were running the simulation, they were run in parallel, and the outcome of one simulation was actually the input of the other, so it's the outcome is consistent. Moving on to the visual comfort. If you look at the roof, it's a quite complex roof. It's too close. It's quite complex roof and has changing pattern in the glazing ratios, but however it also has a very complex layer of brise-soleil underneath. So one person who's coming from the outside, where open to the sky, walks into the corridor, could feel the visual discomfort. So we had to do the spacing accordingly and make sure there's a balance of both visual and solar gains. But at the same time, the lowest walkway had the issue of the reduced daylight levels. So we played around with the glazing area on the roof and the cutouts in the lower plate in order to increase the lighting levels on the lowermost floor. And as you can see in the simulation, we captured that each of the options had different impact on the lux levels. Sometimes it's also not about a very technical simulation that we have to present to the client. For example, in this case, the Chinese client did not understand the language very well. We could not communicate, but very simple shadow analysis through Rhino could give them a sense of the project. Thermal comfort. Before we did the thermal simulations, we had to understand how a person perceives different temperatures when they're outside in the sun as compared to when they are under the roof, where they have brise-soleil and then the glass. We also, through a combination of CFD and parametric tool modeling, experimented with the matrix where we plotted the perceived temperatures. Now in Shenzhen, there could be days where it could be absolute still, but because of the change in the temperatures of the surfaces, there would be still some air movement, and we showed that through simulation with CFD. However, that's not enough, so we introduced industrial fans of approximately 8 to 10 meters diameter to increase the air movement and see the impact on the perceived temperatures. Finally, the rain protection. This is something that was the biggest concern of the client, not because of the rain protection itself, because no one understood the scale of the impact of it. But during the time of the typhoons, the buildings are anyway shut, so we had to design for the time when there's normal average rainfall. In order to do that, we have to understand what's the shape of a rain droplet. It's spherical, it's non-spherical, but it's absolutely not teardrop. Again, we introduced the wind velocities to the airdrops to see how far it travels, to see the impact on the walkways. We also looked at the rain louver design in different scales, from macro to micro. And this is a simulation that shows the effectiveness of the rain louvers the blue dots actually are the smaller particles, and one walking underneath them would actually feel them as a mist experience. Also, we did the simulation on the overall scale, and you can see wherever we have the green dots are the areas that they're not walking. There will be wet zones, however the grey ones indicate that the dry zones. And finally, a video that this beast is real and it's not a hypothetical scenario.
Okay. Couldn't stop that. Great, thank you, Shikha.
Thank
Good
you.
job, great job. One question from the judges, please.
A lot of information there in a very short amount of time, well done. Very interesting project. Did you find the scale of the project actually presented complexities that could be resolved in terms of getting the resolution of the modelling correct?
Well, for the CFD, we had to actually use the high cluster modeling, and we have to kind of split. So it's a complex project, and there's sections that keep changing throughout the complex. We had to identify the worst case scenario and something that represents the whole model because of the scale and everything. And those Revit files that we received from the client and architects were crashing all the time. So you have to kind of scale it down to the problem, layer up with, try to mimic the other complexities around it, and then run with the fair assumptions. And that's what we do. Hope that answers your question.
Thank you very much.
Great job, Shikha. Well done.